You know, there is this really specific moment in just about every classic heist movie. You know the one I mean.
Oh, I think I do.
Yeah, the team has spent months planning the job. They have built the gadgets. They have drilled the vault. They dodged all the laser beams, and they finally have the diamonds in the bag. They walk out the front door. They are high-fiving each other. And that is usually right when the getaway car explodes.
That is the perfect analogy for where we are today. And honestly, it is a little too accurate for comfort when it comes to enterprise AI projects.
Welcome back to the deep dive, everyone. We have been on this absolute marathon journey through the CPM AI framework, the 7 patterns of AI. We scoped out the business problem way back in phase 1. We wrangled the messy data in phase 2. We built and trained the model in phases 3 and 4. We evaluated it to see if it actually worked in phase V. And now,
Now you are at phase 6, model operationalization, the exact moment the rubber finally meets the road.
right, or to keep that heist analogy going, the moment you realize the getaway car will not start because nobody actually checked if it had gas.
Exactly. Let's really hope it doesn't come to that.
Yeah, but looking at the source material for today, it seems like phase 6 is where a massive number of AI projects just go to die.
hmm
And I have to ask, why is that? I mean, we did the hard math part already, the model works. Why is this specific part so dangerous?
Well, it is because people mistake finishing the code for finishing the project. Phase 6 is incredibly deceptive. It looks like a ribbon cutting ceremony. You think the model works, let's just turn it on and go grab lunch. But phase 6 is not a ceremony at all. It is a migration.
A migration.
Yeah, you are moving this really fragile, highly complex piece of mathematics from a sterile, perfectly controlled laboratory environment into the extremely messy, chaotic real world.
So it isn't just a simple go live button that IT presses.
Far from it. And this phase is unique in the entire CPM AI framework because it holds two totally opposing positions at the exact same time. It is explicitly the end of the current project cycle. You are closing the books on this specific build, but it is also the very beginning of the model's actual life as a functioning product.
I see, so it's that whole circle of life logic.
Precisely. And if you are doing it right, it is the setup for the next project cycle. If you just treat this as the end, you're going to have a very expensive, very useless paperweight sitting on your server in about 3 months.
That makes total sense. Now, before we get into the disasters, I know we are going to get into some good disaster scenarios today. I want to ground this for you listening right now, especially if you are deep in the book studying for the PMI CPM AI exam. We have been tracking these phases completely linearly, phase 1, phase 2, phase 3. So obviously this is phase 6. But looking at the exam outline, the eco, it gets a little fuzzy right here.
It does get fuzzy, and this is a major trap for test takers.
Yeah.
If you are looking at the CPM AI course materials, this is clearly labeled Phase 6, nice and simple.
Oh, yeah.
But if you are looking at the PMI exam content outline, the EKO, you really need to shift your mental map.
So where does phase 6 actually live in the EKO?
You are not going to find a domain called Phase 6. The content we are talking about today is primarily tested under Domain V, which is Managing AI. Specifically, that is Task 2, deploying models for production.
Okay, managing AI. That tracks. We are managing the deployment process.
Right, but wait, there is actually more to it. Because Phase 6 is so heavily focused on safety and monitoring and governance, a huge chunk of the exam questions about this phase actually come from Domain 6, which is trustworthy AI.
Oh, interesting. So if I'm taking the test and I see a question about, say, ensuring the model can explain its decision to a user, or maybe checking if the model is being hacked by an outside actor, that is technically phase this operationalization work, but I need to be wearing my trustworthy AI hat to answer it correctly.
That is exactly the mindset you need. The exam is not going to just ask you to list the 3 bullet points under task group 1. That is way too easy. It is going to give you a real-world scenario. Something like a model was deployed 3 months ago, it is suddenly failing, and nobody in the organization knows who is actually responsible for fixing it.
Wow, so that is a deployment failure, a monitoring gap, and an accountability issue, all wrapped into one messy situation.
Exactly. And you need to recognize that scenario as a total collapse of Phase 6 operationalization.
That definitely raises the stakes.
Yeah.
It is clearly not about just memorizing lists. It is about really understanding the whole ecosystem. So let's build that ecosystem out for the listener. We have 4 big task groups to get through today. Let's start with the one marked as a HEH priority, the Model Operationalization Plan.
This is your blueprint, the master document.
So I have to play devil's advocate here for a second. I am a project manager. I obviously love a good detailed plan. But do we really need a formal documented plan just for this? The data scientist has all the code on their machine. The IT team has the cloud servers. Can't they just slack each other the files and spin it up?
What you just described is what we call the informal handoff, and it is easily the single biggest cause of deployment failure in the real world.
Really? Just an informal handoff causes that much damage.
Why? Because the phrase, "it works on my machine," is not a valid deployment strategy. Think of the operationalization plan as scaffolding. When you build a giant skyscraper, you don't just magically stack bricks on top of each other. You build a massive temporary structure to support the transition from a pile of materials to a standing building.
Right.
This plan details exactly how the model moves from the safe development environment to the live production environment. And those two environments are almost never the same.
Which perfectly leads us to a concept in the source material that I found absolutely fascinating.
Oh.
And that is the strict distinction between training and inference.
Oh, this is a deep dive essential. If you take only one single technical nugget away from this entire discussion today,
Yeah.
let it be this. The training pipeline and the inference pipeline are two completely different beasts.
Let's really unpack that. Training is essentially the gym, right?
Training is the gym. It is where you build the muscle. Back in phase 4, you took these huge historical data sets, maybe hundreds of terabytes of data, and you just crunched them. You used massive GPU clusters. You ran processes that took 12 hours, maybe 24 hours, sometimes an entire week to finish just one run.
Okay, so it is heavy lifting,
Yeah.
slow and steady. You have all the time in the world, relatively speaking, because it's happening behind closed doors.
Exactly. But now you move to phase 6. You are deploying for inference. Inference is the game. The model is now live in the real world. It is taking brand new, unseen data and making a prediction on the spot.
And the rules of the game change.
Completely change. Let's say you built a fraud detection model for a major credit card company. You trained it on 5 solid years of transaction history. That training run took 2 days to complete. Now, you take that model and you are at the grocery store checkout. You swipe your actual credit card. How long are you realistically willing to wait for that model to decide if your transaction is fraud?
Maybe a few milliseconds. If it takes 12 hours, I am definitely leaving my groceries on the belt and walking out of the store.
Exactly. And that right there is a latency requirement. If your operationalization plan assumes that you can just use the same heavy, incredibly slow infrastructure for the live game that you used in the gym, you fail instantly. The model mathematically works, it is highly accurate, but the actual product is broken because it is just too slow for human use.
So the plan essentially has to translate the giant brain of the model into a body that can actually move fast enough for the real world.
It is not just about speed either, it is about cost. Training burns a massive amount of energy and money, but you only do it once in a while. Inference happens millions of times a day. If your model is too heavy, like if it requires a $10,000 graphics card for every single transaction, you might go literally bankrupt just running the thing.
I see. So the operationalization plan is the moment that forces the data scientists and the IT engineers to sit down in a room and ask, can we actually afford to run this thing? Does it physically fit on the chip we have? Is it fast enough to meet the business need?
Right. It bridges the gap between the pure science of phase 3 and the practical engineering of phase 6. It helps you determine if you need to do things like model quantization before you go live.
Quantization. That definitely sounds like a buzzword from a sci-fi movie.
It sounds super fancy, but it basically just means compressing the model. Maybe you agree to trade off 1% of your overall accuracy for the ability to run that model on a $2 chip inside a security camera instead of needing a giant cloud server. That is a massive operationalization decision.
And if you don't have a formal plan, you simply don't make that decision until the massive AWS server bill arrives at the end of the month and everyone panics. Another key part of this plan that caught my eye in the notes was procedures for model updates and version control. Now, coming from a traditional software background, I know all about Git, I know versioning. Is this really any different for AI?
It is fundamentally different. In standard software engineering, if you release version 2.0 of an app and it has a critical bug, the app usually just crashes. It throws an error code. It is binary. It works or it doesn't.
Right, you get the blue screen of death and you know it's broken.
But in AI, version 2.0 might run perfectly fine from an IT perspective. No crashes, no error codes, the server health looks great, but the actual decisions the model is making might be significantly worse.
So it's just quietly losing the company money in the background.
Right. So your operationalization plan needs a highly specific, documented procedure for model updates and rollbacks. Let's say you deploy a brand new dynamic pricing model. It is running live on your e-commerce website. Suddenly, your daily sales drop by 20%.
That is full panic mode.
Absolute panic. And you definitely don't want to be sitting there trying to figure out how to manually undo the deployment while the CEO is screaming at you. You need a documented, tested undo button, a procedure that explicitly says, if key metric X drops by this amount, we immediately and automatically revert to version 1.0.
So if I'm sitting for the exam and I see a scenario where a whole team is frantically scrambling to find the old code repository because the new model is failing in production.
That is a total failure of Phase 6 planning. They simply didn't plan the rollback procedure.
It really seems like the operationalization plan is basically just highly formalized professional risk management.
That is a perfect way to summarize it. And there is one more critical piece to that plan: managing data lifecycles.
Now, we talk extensively about data way back in Phase 2. Why are we bringing data back up here at the very end?
Because back in Phase 2, you were dealing with a static, dead data set. You had a CSV file or a database dump. But in Phase 6, you are connecting your model to a live, flowing pipe of data. You have to manage that lifecycle. What happens if the actual format of the data coming from your live website suddenly changes?
Like the pipe just bursts.
Or it silently leaks? Imagine your website team updates the user profile page, and they change the gender field from M and F to male, female, and other. But your machine learning model was only ever trained to understand M and F.
The model is going to completely break when it sees those new words.
It will either crash or, worse, just spit out garbage predictions. The operationalization plan defines the strict contract for the data. It explicitly states the input data MST look exactly like this, or the system rejects it.
Okay, that makes total sense. So we have the plan documented, the scaffolding is fully up, we know exactly how you're getting the model out there into the wild. Now we move to what really feels like the heavyweight champion of this entire phase, Task Group 2, model monitoring and maintenance.
This one is marked critical priority. And frankly, if you want your project to survive long-term, this is the most important part of the entire life cycle.
Now, the source material makes a very distinct separation here between operational surveillance and the accountability structure. To me, that sounds a little bit like corporate speak for just keeping an eye on things. What is the actual practical difference between those two?
I like to think of it like a bank. Operational surveillance is the network of security cameras and the laser alarm system. It is purely physical. It watches what is happening. The accountability structure is the bank manager, the legal third, and the local police force. It defines exactly who is responsible and what action is taken when that alarm actually goes off.
I love that. Okay, so let's start with the cameras. The monitoring and maintenance plan. This is task A. How is monitoring an AI model fundamentally different from just monitoring a standard website or a database? I mean, we have all these existing IT tools that tell us if a server is up or down. Green light means good, red light means bad.
Right, but standard IT monitoring only checks for availability. Is the server powered on? Is the API actually responding to pings? That is great, but an AI model can be fully up, green lights across the board, 10-millisecond response time, and still be completely and utterly brain dead in its output.
So the lights are on, but nobody's home.
Or worse, someone is home, but they are actively hallucinating. Standard monitoring checks the container. AI monitoring has to check the actual contents. We need to continuously check for drift.
Drift. That is the massive buzzword. Now, we talked about drift way back in Phase V, the evaluation phase. But it means something a little different here in Phase 6, right?
Yes. In Phase V, you are evaluating past drift to make a go or no-go decision on launching. It's a gatekeeper. But in Phase V, you are literally building and installing the live sensors to detect drift as it happens in the future.
Can you really clarify the two main types for us? Data drift versus model drift. I feel like those are so easy to mix up on an exam.
Absolutely. Let's start with data drift. Think of a retail AI. You train it to recognize cool, trendy outfits based on thousands of photos from the year 2019.
Okay, so lots of skinny jeans, maybe some specific sneakers.
Right. And then the year 2020 hits. Suddenly, the input data totally changes. Everyone is staying home. Everyone is wearing masks and sweatpants. The entire world, the actual data being fed into the system, has drifted completely away from what the model was originally trained to understand. That is data drift.
So the inputs change. The actual photos look fundamentally different.
Precisely. Now contrast that with model drift, which is sometimes called concept drift. Imagine you build a machine learning model to predict housing prices. It uses a feature like square footage to predict the final price. That relationship is usually very stable. bigger house means a higher price.
Sure, that's just basic real estate logic.
But then a massive economic crash happens. Or maybe a specific, highly desirable neighborhood suddenly becomes unpopular because a loud, polluting factory opened up right next door. Suddenly, a 2,000 square foot house in that area is worth significantly less than it was just a month ago.
But the square footage didn't change.
Exactly. The input data, the square footage, didn't change at all. But the underlying relationship to the output, the price, fundamentally changed. The actual logic and rules of the real world shifted beneath the model's feet. That is model drift.
So if I have this right, data drift is when the players on the field change. Model drift is when the actual rules of the game change.
That is a fantastic way to put it. And your Phase 6 monitoring plan absolutely has to catch both. Because if you don't, your model will just confidently continue to predict 2019 fashion trends in a 2024 world, or price houses based on a booming economy during a recession, and your business will lose a fortune.
And this isn't something a human could just spot check on a Friday afternoon, right?
Not at an enterprise scale, no. You might have millions of predictions happening daily. You need automated triggers. That is where the maintenance triggers part of the plan comes in. You preset hard thresholds. You say, if overall accuracy drops below 85%, sound the alarm. If the input data distribution shifts by more than 10% from our training baseline, sound the alarm.
It totally removes the ambiguity. You don't want to be sitting in a committee meeting debating, well, is it bad enough yet to turn it off? The mathematical system just tells you it is bad enough.
Exactly. It moves the human hesitation. Now, there is another critical layer to this monitoring plan that brings us squarely into domains of this trustworthy AI, and that is security monitoring.
Are we talking about traditional hackers here, like stealing passwords and data breaches?
We are talking about malicious actors, yes, but not in the traditional sense. We are talking specifically about adversarial attacks against the AI itself.
Give me a concrete example of that.
Okay, imagine you have a highly sophisticated image recognition system deployed for a fleet of self-driving cars. Its job is to read speed limit signs and stop signs. A bad actor could go out and put a specifically designed tiny sticker on a physical stop sign. To you and me, it just looks like a random piece of graffiti or some dirt. But to the AI, that specific mathematically calculated pattern of pixels completely tricks the neural network's weights. It suddenly thinks that solid red stop sign is actually a speed limit 45 sign.
Oh, wow, that is absolutely terrifying. The car just blows right through the intersection.
It is terrifying. That is an adversarial input. And standard IT monitoring will never catch that because the camera is working, the file format of the image is perfectly valid, and the server is responding quickly. You need specialized AI-specific security monitoring that constantly analyzes the inputs for these weird statistical anomalies.
Okay, so that covers the cameras. The monitoring is our eyes and ears. Now let's talk about the laws and the police. The model governance framework. This is task B under this group.
This is where the project manager really truly earns their paycheck. Because this entire task is about liability.
Liability, like who goes to jail if this thing breaks the law?
Well, hopefully nobody is going to jail, but yes, essentially. Governance fundamentally answers the hardest question in AI: who owns the model's behavior in production?
But isn't it obviously the data scientists who built it?
This is the absolute most common trap organizations fall into. The data scientists built the car, yes, but they do not drive the car every day. Once that model is officially deployed into production, the ownership usually has to transfer to the business owner or the operations team. The governance framework makes that transfer official and legally documented.
Why is that formal transfer of ownership so incredibly important?
Because think about it from a timeline perspective. 6 months from now, if the model suddenly starts denying bank loans to a specific minority demographic unfairly, that original data scientist is likely already neck-deep in building a completely different model for a different department. They aren't watching it. The business owner, the VP in charge of the loan department, needs to be the one who is legally and operationally accountable for saying, stop the model, pull it offline.
So the governance framework essentially prevents the corporate game of not it when things go wrong.
Exactly. It forces accountability. It also establishes the hard policies. For example, a formal governance policy might dictate we never allow the AI system to automatically and silently reject a human being's job application. All AI-driven rejections must be flagged and reviewed by a human HR representative.
That is a classic human-in-the-loop policy.
Right. And if that specific policy is violated in production, that is a massive governance failure, not necessarily a technical failure. And that leads us to the final, crucial piece of governance audit trails.
The black box flight recorder for the AI.
This is literally your defense in a court of law. Fast forward 2 years. A government regulator comes into your office and asks, why exactly did your system deny this specific customer a mortgage on February 23rd, 2026?
And saying, well, the black box computer just said so, is probably not a valid legal defense.
It is considered gross negligence. You need a rock-solid audit trail that definitively shows here was the exact input data we received. Here was the exact version of the model running at that millisecond, say version 1.2. Here was the mathematical output score. And here was the explainability report that justified that specific decision based on our established policies.
Complete traceability from input to output.
Traceability is everything. Without traceability, you do not have a managed business process. You just have a magic 8-ball making financial decisions. The exam absolutely loves testing scenarios about this. If you are reading a question and it mentions compliance, regulatory audits, or legal liability, you are squarely in the territory of the model governance framework.
It really feels like this entire task group is the defining difference between a fun college coding project and a serious enterprise product. The school project obviously doesn't need an audit trail or a lawyer, but a global bank does.
Exactly. And that is why the CPMAI framework places such heavy critical emphasis on this. It is all about transitioning to professional AI management.
Okay, so let's summarize where we are. The model is live in the wild. We were actively monitoring it for drift and hackers. We have the business owners and the lawyers happy with the governance structure. So are we done? Can we go home?
You know the CPMAI motto by now?
It is a continuous cycle.
It is a cycle, which brings us perfectly to Task Group 3, determine requirements for the next iteration.
Now, this is also marked as a HIGH priority. But I have to ask, on behalf of exhausted project teams everywhere, everyone has been working overtime. We literally just launched this thing. Why can't we just wait until the next quarterly budget cycle to worry about next steps? Let people rest.
You have to do it now because of the fresh wounds theory.
The fresh wounds theory. That sounds
Right.
incredibly painful.
It is a little painful, but it's true. Right now, at the exact moment of deployment, you and your team are the absolute smartest you will ever be about this specific project. You know exactly what failed. You know exactly which data sources were a total nightmare to clean. You know exactly which cool features you had to ruthlessly cut from the scope just to meet the launch deadline.
And if you don't take the time to formally write all of that down right now,
You will completely forget. 6 months from now, when you finally get the budget approved for version 2.0, you and the team will look at the old code and say, why on earth did we build it this way? And you will end up repeating the exact same painful mistakes.
from a PM perspective, this also seems like a fantastic tool for managing scope creep during the build phase, doesn't it?
Oh, it is the ultimate project manager weapon for scope creep. Picture this. You are in phase 4, you are deep in model training, and a major stakeholder knocks on your door and says, hey, I just had a great idea. Can we add this massive new predictive feature to the model? And you know for a fact that adding it will destroy your timeline and your budget.
You just tell them no.
But you don't just say a flat no. You say, that is a truly brilliant idea. Unfortunately, we cannot fit it into the architecture for Launch 1.0 without risking the whole project, but I am going to formally document your idea right now as a priority requirement for the next iteration in Phase 6.
Ah, the classic yes, but later strategy.
It works perfectly. It makes the stakeholder feel heard and valued. It captures the good idea. But crucially, it aggressively protects your current schedule. And when you reach Phase 6, you actually pay off that operational debt by formally documenting it. This specific task is the physical bridge between the end of this current project and the start of the next Phase 1.
So if a team just shuts down the project and skips this task, they literally break the circle.
They break the entire iterative life cycle. You stop doing CPMAI and you are just doing ad hoc, disjointed IT projects. You are back to being an amateur organization.
And I imagine the exam writers will definitely test that linkage.
They absolutely will. If a scenario question asks what the primary input document is for a brand new project's Phase I, the strongest answer is very often the next step's output from the previous project's Phase 6.
The circle always connects.
It has to connect.
All right, finally, we have reached the last part. Task Group 4 Project Report. This one is marked as a medium priority, so we won't spend as long on it, but it is still required.
Right. This is standard foundational project management hygiene. I call it the receipt and the retrospective.
Let's start with Task You Produce Final Report. You call this the receipt.
It is very straightforward. Did we actually do what we said we were going to do? Way back in Phase I, we sat down and set clear business objectives. We said, this model will reduce customer churn by 5%. Here in phase 6, we check the receipt. Did we actually reduce churn by 5%?
So it formally documents the final deliverables against the original success criteria.
Exactly. It creates the permanent organizational record. Because if you don't have this documented proof, you cannot mathematically prove your return on investment. And if you can't prove your ROI, good luck ever getting funding for your next AI project from the finance team.
Very true. And then we have Task B Review Project, the retrospective.
That is the maturity check for the whole company. It is taking a hard look at the process itself, not just the technical product. For example, maybe the deployed model is amazingly accurate, but during the project, it took the legal department 6 full months to approve the data access request.
Right, so the math was fine, but the corporate process was a failure.
Exactly. A crucial lesson learned for next time is we must start legal engagement on day 1 of phase 1, not phase 3. If you do not capture that human process failure in the retrospective, your team is going to be stuck waiting on legal for 6 months on every single future project. This task is fundamentally how an organization gets better and faster at AI over time.
It is not just about squashing the technical bugs in the code. It is about squashing the human bugs in the company.
The political bugs, the communication bugs, the why did we have a 2-hour meeting with 12 people about dashboard font sizes bugs?
We have definitely all been in that meeting.
Oh, we all have. Phase 6 is where you formally write those lessons down so nobody has to suffer through them again.
So just taking a step back and looking at phase 6 as a whole, it really feels like the adult in the room phase. Phase I is all visionary and blue sky thinking. Phase 4 is deep technical wizardry and coding. But phase 6 is the strict adult supervision.
That is actually a really perfect framing for it. In all those earlier phases, your core identity is a builder. You are creating something new. But the second you cross into phase 6, you have to transition your mindset. You become a guardian.
A guardian, I really like that distinction.
You are no longer just delivering cool Python scripts. You are delivering a fully governed, highly regulated enterprise system. You are taking on the responsibility of ensuring it is constantly watched, tightly controlled, and that the wider organization actually learns from the experience.
And that mindset shift really loops right back to how you approach the exam. The questions in this area aren't just going to be about tweaking hyperparameters in Python. They are going to be asking, how do you ensure this live system is legally safe, practically sustainable, and accountable?
Correct. If you are sitting for the test and you can successfully shift your mental framework from coder to guardian, you are going to absolutely crush the domain V and domain 6 questions.
Well, we have certainly covered a massive amount of ground today, from the gym versus the game concept and operational infrastructure to setting up automated drift sensors, all the way to building bulletproof legal audit trails. It is incredibly clear that just because the coding is done does not mean the project is finished.
Done just means the model is live, and live simply means the real work of managing it is just beginning, which honestly is the whole point of having a structured lifecycle framework in the first place. Without it, you just have a bunch of rogue algorithms running your business.
That is a slightly exhausting but incredibly important thought to leave our listeners with. Think about the zombie models running out there right now. Making decisions without any monitors or audit trails. Make sure yours isn't one of them. To everyone listening, whether you are prepping hard for the exam or you are gearing up for a stressful deployment next week, please do not skip the scaffolding.
Build the bridge to the next iteration. Don't let your project be a dead end.
Excellent advice. Thank you so much for diving deep with us on Phase Zia today. We will see you. Well, since it's a continuous circle, I guess we will see you right back in Phase I for the next cycle.
See you in the next iteration.
Bye for now.